David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit you. You can also pause a video at any point and jot down notes or write down questions for our next class. Lastly, you can turn on the captions and read my words on the screen. So far in our exploration of quadratics, we've been determining graphs from equations. And you've learned a lot of techniques from manipulating equations, changing forms, and finding all the important parts like intercepts, where's the vertex, axis of symmetry, and so on. So this lesson is going to go the other direction. We're going to wind up looking at graphs and determining the equations based on the information in the graph. But I felt like it would be super important at first to do a nice quick little review of the 3 forms and what things are easy to get from those forms and what things take more steps. Maybe they're not difficult, but they take more steps. So let's take a look. So vertex form. Let's talk about the easy things. What's easy from vertex form? And the first answer for that, actually, let's stop for a second. If you want to fill this out, you should write easy or steps in each of these boxes. So that might be a really good little activity to do. Pause the video, copy this part into your notes, and then think real hard which things are easy from each form and which things take steps. So I'm going to go ahead and explain as we go. Vertex form, easy on the vertex, and that also means it's easy on the axis of symmetry since that's just the x-coordinate of the vertex. You can get to these, but you have to convert to a different form. So this is going to be steps. Okay, now, general form. What's easy for general form? It's the y-intercept. That's the only thing that's easy. You can just get it right off the form. The rest of the things are going to take steps. So in a way, general form is maybe our least helpful form for a quadratic. Finally, take a look and think about factored form. What's easy and what takes steps? All right, last thing, the shape of the parabola. Is it open up or down, and is it compressed or dilated, expanded or stretched? So think about these 3 forms, and what about the shape? What about the A term? Okay, it's easy in all of them. The A term is the same across 3 forms. So we're going to put easy, easy, and easy. So this is helpful because what you're going to get now are graphs that are going to give you certain bits of information. It might show you the vertex and the y-intercept. It might show you the 2 x-intercepts, things like that. So you're going to have to use the information you get on the graph to create an equation for it. So the easiest thing to do there is to look at the stuff you have, the intercepts, the axes, etc., and figure out which form is easiest to start with based on what you have. And then you're going to need to do some steps either to flesh out the form, find some other component that you need, or convert it to a different form. I'd like to spend another minute reviewing what we get out of each of the 3 forms. So that table was a quick little summary, but now we can take a look at specifics. So check this out. I've got our 3 forms here with their form with just the letters. And just a quick summary here. Vertex form gives you the vertex, gives you the symmetry axis. If you want to make a good graph, you have to use the A term to figure out the shape, up or down, narrow or wide. Moving on to factored form, here we get the x and y intercepts right out of the equation, and with a little calculation we can get the symmetry axis and the vertex. Finally, in general form, we get the y-intercept for free, and then we do have to do a little calculation. We get the symmetry axis and the vertex. So that's a summary of basically the coordinate points that we can pull out of these 3 equation forms for a quadratic equation. All right, let's do an example. So what we're going to do is we're going to use the information in this graph here to write the equation for the function that makes that parabola. So here's your prompt. Use the information shown in the graph to write the function's equation in general form. Now you're going to want to pay attention to the destination form because that might determine where you start. So I want you first just take a look at that graph and make a judgment call. What might you start? You have 3 intercepts. So that is enough information. I can actually think of a couple pathways to write an equation. So pause the video, think about that. Okay, so for me, if I have the 2 x-intercepts, that's a pretty good place to start. So what I'm going to do is f of x equals a times x, and that's a -4, so this one's going to be +4 times x minus 3. Now that gives us a good start. So why don't you go ahead, pause the video, and manipulate this. There's a bunch of steps here to turn it into general form. Remember, we're going for ax squared plus bx plus c. And there's actually a couple steps before you can get there. All right, so I'm curious to know how far you got. What we have to do here is we also have to use our y-intercept, plug that information into the equation, and then we can find out what a is. So let's think about that. The y-intercept happens when x is 0, and then y is -24. So that allows us to do this. -24, that's the y value. That's going to happen when x is 0. So 0 plus 4 is going to be 4, and then 0 minus 3 is going to be -3. So now I have one equation in one variable. I can solve this. -24 equals -12a. Divide through by -12. I'm going to get a equals 2. So now I found my a. What I'd like you to do now is pause the video, use what you know about a, plug it back in somewhere along there, and see if you can get the general form equation for this quadratic. Okay, so what I did is I just plugged my a in to my general form from up here, and I multiplied my binomials, got that, then distributed my 2 through, and I get f of x equals 2x squared plus 2x minus 24. And that's my general form equation for that parabola. And notice how when I got to the end of it, my y-intercept is -24, and that does match my graph. So that's a little confirmation that at least part of my math is correct. Let's do another one. Same prompt, different graph. And now this graph gives us different information. We have the vertex and the y-intercept. So again, we're shooting for general form. So I want you to pause the video and think about what you're going to do as your first step with that graph. Often that's the hardest part of these problems. You've got to figure out where you're going to start. Okay, if you thought about vertex form, you're right. We have the vertex. So that helps us quite a bit. So what I'm going to do here is I'm just going to write down my vertex form equation with what I know. So it's going to be a, we don't know that yet, times x minus h, or actually we have a 2. We know that that's -2, but we know the sign changes, squared minus 2. So now we are part of the way there. Now I want you to pause the video and figure out what goes next. This is similar to what we did last time. So in this case, like our last graph, I used the y-intercept to eliminate all the unknowns except for a, which we're going to find in just a minute. So I know that when it crosses the y-axis, the y value is 4 and the x value is 0. So I just did a plug-in with my 0 and my 4, and now I can manipulate that and solve for a. So go ahead and do that. All right, so when I manipulate that through, my 0 gives me just a -2 squared there, which becomes 4. So now I have a times 4 minus 2 is 4. Add 2 to both sides. Finally divide through by 4, and I get my a is 3/2. So now take what you've learned here, plug back in, and get the general form equation for that graph. All right, let's see how you did. So what I did is I just plugged in my a there, and then I have my vertex coordinates there. Now I square my binomial. I get x squared minus 4x plus 4. I multiply through by my 3/2 on each of these 3 terms, and then I subtract 2 from my constant at the end, and I get 3/2 x minus 6x plus 4 as the equation for that quadratic function. Last problem. Again, we're going to shoot for general form. So here's our graph. And you'll notice that we've got two x-intercepts, but no vertex, no y-intercept. You just have a third point that's somewhere on the function's graph. So pause the video for a sec and figure out how you're going to start this problem. What are you going to do? So what I'm going to do here is I'm going to start with my two x-intercepts. I have a form that's specifically designed for those. It allows me to use my 2 points right away in the form. Okay, so now pause the video, and what are you going to do next? How are you going to use that third point in this equation to move the math forward? All right, so what I'm going to do is use my third point just like I used the vertex or the y-intercept. In fact, I can use any third point if I already have my two x-intercepts. So what I did here is I just plugged in the coordinates for that third point. The y value is -18, the x value is 2. It's the same x in both places, and so I just run my equation. I have, this ends up being a times 6 times -1, which is -6a, divide through, and I'm going to get a is 3. So now, pause the video and finish converting or finish creating the function's equation in that form. All right, so all I did was I plugged my 3 in here in my factored form. I expanded my binomials, multiplied them out, multiplied the 3 on through, and there is my function's equation. Now that you've watched the video, take a moment to write down some notes or questions or a short summary of the lesson. You can also re-watch portions of the video that you didn't get so well the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.